Hello there, ROS developers, and welcome to a new live class number 130, where we are going to be working with a NanoSaur robot with ROS2. So let's go for it. Alright, so welcome everybody, welcome ROS developers to a new live class. We are back after 1 week where we took some rest of live classes, so we are back now with live class number 130, and as I have just said, today we are going to be working with a NanoSaur robot. You are going to I don't know if you already know about it. If not, you are going to know about it today in today's live class. And we are going to basically be working with a Gazebo simulated version of this robot. We are going to show how to create the simulation and how to create a basic ROS2 program, because this robot is based on ROS2. So we are going to be working on ROS2 Galactic. We are going to create a very simple script to control it, etc. But this is not a regular live class, because it is part of a bigger series of live classes which is going to take the whole month of November. So instead of just talking here through the camera, let me start everything up, and I'm going to open the project and explain you from there, because there are some things that I need to explain to all of you before we get started with this live class. So yeah, let's go for it. Then I'm going to right now change to my computer screen. There we go. So, okay. So, yeah, as always, remember, we are going to come here to the workshops page. Here we have the current live class, which I'm going to mute myself. Then, as always, if you are new, you have to know that you need to click here in this fork and open the class project. This is going to basically create a copy of today's project in your account. It's going to basically, and it's going to automatically open it also, as you can see, in my case. Then here in the right side, you are going to have the streaming area panel, let's say, where you can follow the video, you can hear to what I am saying, see what I am doing, etc. You have also the chat here, where I can see that some of you have already said hello there. Richard Cushing, Needy A, Joel Friends, who is saying hello from Virginia, USA. Hello there. Edgar Carrasco also. By the way, Edgar Carrasco, I think that Edgar, you were in the workshop last week. Can it be? Because your name kinda sounds familiar to me. I think that you were in the workshop we did last week. All right. Also, Raffaello Bonghi, of course, the creator of the NanoSaur robot. So as you can see, today's live class is presented to you by The Construct, in collaboration, of course, with Raffaello Bonghi, who is a friend of us, and who is the creator of the NanoSaur robot. So we have here in the chat the creator himself. So, yeah, welcome everybody. Also, Thomas Schoen, hello there from Germany, he's saying. All right, so yeah, let's start presenting a little bit this live class, because as class, it's going to be it's the first part of a series of live classes that we are going to be doing during this month of November. And all these live classes have one thing in common, which is that we are going to be working with the NanoSaur robot. So basically today's live class, which is November 2, we are going to be working with a Gazebo simulation version of this robot, which is not available by default, so we had to create it, let's say. Then I'm going to explain a little bit about this process, not too deep into it. Then the next live class, we are going to be performing some AI based on ROS2, also with the NanoSaur robot, and still in the simulation. So we are going to keep working in the simulation. Okay. Then on November 16, the third live class of this series, we are going to be building in the live class the real NanoSaur robot. So we have all the pieces, so we are going to be building it here live. We are going to do a special setup with a camera so that you can see all the process. It's going to be a super interesting live class. Then on this third live class, we are going to be building the real robot step by step from zero. And finally, on the last live class on November 23, we are going to connect to this real NanoSaur robot in order to control it. And we are going to show you this process of how you can connect from anywhere in the world. You can create even your own laboratory to connect here from ROS-DS to the real NanoSaur robot. So the idea is this one, okay? If you want to, the best way to follow these live classes would be that you do all of them with us. Then, if you don't, of course, you can just come to the live classes and follow them. But if you are interested in also following all the real NanoSaur robot part, then of course you are going to need the pieces. Then for that, I have added here, I'm going to explain a little bit about it now also. I have added a bill of materials so that all of you can purchase the pieces. And you can join us in the process of building from zero this real NanoSaur robot and working with it and connecting to it, etc. So, first of all, I have also shared here, of course, the official NanoSaur website. So you can click on it and have a look. It's super interesting, super well built. And you're going to find many, many interesting things. Even they have a Discord server, which I find especially cool. And yeah, the wiki, all the process. So let me explain a little bit about the bill of materials, because I have divided it in different sections, let's say 3 sections. First of all, I have shared here a table, as you can see, with the main materials to buy and links to where to get them. So here you have all the links. If you click on them, it's going to take you to directly to the page where you can buy it. All right. So you have here all the main components. Let's call it like this, and you are going to find links so that you can directly purchase them. You have links to Amazon.com. So if you are based on Germany, maybe it's going to be better for you to look to your own Amazon link, because it's going to be probably cheaper, all the shipping, etc. So here I have shared the US-based, let's say, Amazon links, all right? So if you are based in other places, you can have a look there. Also, I think that in the main page, if I'm not mistaken, I think that Raffaello shared also some links based on countries, if I'm not wrong. Let me have a quick look. Yeah, so here you have some also specialized links, for instance, the US-based, Italy-based. Okay, so you can have a look also here directly. So yeah, this would be the main materials, let's say, main list of materials. But then we have the expansion board. Okay, or Raffaello is saying also, or you can find on Discord channel. So. Okay, so I suppose you are talking, Raffaello, about the bill of materials. So also in the Discord channel, maybe you can find some additional information related to it. So yeah, then besides this initial bill of materials, you are going to have to also get the expansion board. Okay, then here I have directly linked here to the section in the official documentation. So basically the expansion board is going to look something like this when built. Actually, I have one here myself. Let me see if I can show it to you real quick. Yeah, let me get it from here. Yeah, so let me very quickly here share to my camera. So if you can see, not very well because it's a little bit far away, but here I have also the expansion board, which it's funny because since the board is green, it's basically invisible here to the camera. So, but yeah, here I have a real one, expansion board already mounted, but let's go back to the computer screen. There we go. So yeah, for this, you are going to have to get some extra materials. First of all is the PCB. So for the PCB, you can get them in the page, which, let me see, which is the link right now. Yeah, I think it's this one. Let me see real quick. Yeah, so here it is. Here you have the link to get the PCBs. Then, as I have been reading a little bit before this live class, basically you are going to have to get a minimum amount of PCBs of 5, but in the first order, this is going to be completely free. So you are going to only have to pay the billing, let's say. Okay, so the costs of the transport, etc. Okay, but the first command is going to be free. Okay, so let me get back here. See, you have all the information here. So the minimum quantity by default is 5. So you are going to get 5 PCBs, but the first order of 5 PCBs is free. All right, so you are going to only have to pay the shipping costs. All right. And then finally, you have some extra things here. You have the list of components here. All right. And you have also some information here. This is all the materials that you are going to need in order to build this expansion board. Right. You have all the information here and a schematic. All right. You can download them, download it, all the process, etc. Okay. Don't worry because, well, this, in fact, this expansion board, you should have it already built. Okay, you have the steps and all the information here. So this expansion board, you should have it already built for the third live class, for this one. For this live class, which is going to be in November 16, you should have this expansion board already built. Okay, this is going to be one step. Then the other step is just to have the bill of materials. You don't have to build anything from here. We are going to do all this together in the live class. And then finally, you have the 3D parts. Okay, you have also the information here. Basically, you are going to need to 3D print all these parts. You have the information here also with the STLs, etc. Then I have shared here an interesting link, which is this hubs.com. Which basically it's a platform where you can upload all the files that you are interested in printing, and they are going to basically create a quotation for you for free. So you can have a look here, or you can go and have a look there in your local stores. Maybe you know some place there where they can 3D print all this for you. And yeah, so you are going to also need this, okay? So let me summarize a little bit this, because maybe it's too much information. So first of all, you have the main bill of materials, which is this one. You can find here the main links based on the US. Also in the main documentation, you are going to find some links more specific to the country where you are based on. And also, Raffaello said that in Discord you can find also information about this. So this is about the main materials, let's say. Then you have the expansion board, all right, which you have to also get some extra materials, the PCB and some extra materials like resistors, switch, etc. Apart from the PCB, which you can get here from the links directly here, which you are going to basically get 5 in the first order for free. You are only going to have to pay the shipping costs, all right? And then besides this PCB, you are going to need to get some extra materials, resistors, etc., which you can get in any regular electronics store, Okay, all of these you can get it in any regular electronics store, or you can buy them also online if you prefer so. That's up to you. And then you are going to have to build this expansion board by your own, okay? Well, you have the Discord channel, of course, where probably you are going to be able to get help there in case you have any issue, but you have also all the information here on how to mount it, etc. It's pretty simple, okay? So you are going to have to do this, to mount the expansion board before the live class, before this live class, which we are going to have on November 16. All right? And finally, you also need to get the 3D parts printed. Okay? Last step is to get the 3D parts printed. Okay? Let me open another link here. You have also all the information here with the files. You can download them here. All the different STL files. Okay, you are going to find everything here. So you need to have the 3D parts printed, you need to get the main materials, order them, and then you need to also build the expansion board. Okay, and then with all these, we are going to create the robot on November 16, on the third live class of this series. All right, let me see. Okay, Raffaello says, yes, I was speaking about the bill of material. For any help, I will be here and there for the other days. Okay, so Raffaello is going to be also in Discord there in case you have any doubt, any extra question. So yeah, you can join here the Discord channel that they offer. Okay, you're going to find it here. I'd be interested on getting a robot. Okay, so here you have all the steps, Gabriela. This is a super nice robot, let me tell you to start with. It's based on the NVIDIA Jetson, which is very interesting, especially for developing on AI, creating AI programs. And also it's super interesting because it's based on ROS2. So you are going to be able to start directly from ROS2, all right? So yeah, I really think that this is a super interesting robot to start with. And yeah, you can come here to the live classes to follow all the process of building the robot from zero with us. Okay, yeah. So all of this is more or less clear. The requirements for being able to follow these live classes. Are these videos available offline later? Yeah, yes, they are. Ashutosh. Okay. Yes, they are going to be available. Once this live class finishes, we are going to upload it to YouTube, the recorded version. So don't worry about that. Everything is clear, says Sajid. All right. So yeah, basically this is going to be the planning. So today it would be good that you start getting all the materials required, which you have everything here, all the reference links. Then in the next live class we are going to be developing on AI, ROS2 AI with the NanoSaur robot, with the simulated version of the NanoSaur robot that we have created for this first class. And then on day 3, November 16, we are going to be building the real physical NanoSaur robot here in this live class all together with you. And then finally, on the last live class, we are going to connect to this real physical version of the NanoSaur robot. All right? The timing is during office hours. Okay, I see. Shutosh. Okay, then yes, don't worry because you are going to be able to access to all these videos after the live class finishes. So don't worry. Everything is clear. Okay, so I think that we are ready to go. Then let's go for it. All right. So let me open here a new shell. And we are going to directly start with the simulation, okay? So today we are going to be working with a Gazebo simulated version of the robot. By default, if I'm not wrong, Raffaello can correct me, if you are still around, that there is already an integration for the Isaac simulator by NVIDIA. I think so. Which is super cool and super interesting. But for this live class, we have created, let's say, we have adapted this to work with a Gazebo simulator. All right. Then we are going to be launching this version, this NanoSaur version for the Gazebo simulator right now. So for that, it's not yet released on Isaac Sim, but yes, okay. So it's being prepared, it's being developed. All right, so let's start working then with the Gazebo version of the NanoSaur robot. So the first thing you have to do here is to open a new shell, which you can do by clicking here in the first icon on the bottom left corner. Here, you can click here, and this is going to open a new shell, which this is just like a regular Ubuntu Linux shell. You can type any commands here. And yeah, so here we are going to run this command. Okay, ROS2 launch NanoSaur Gazebo main.launch.py. You can copy the command directly here from the notebook, or Control-C, which is even faster, and Control-V directly here to the shell. All right, and then run this command. Okay. One integration via Onshape, a second one via URDF file. Okay, I see. So yeah, this is going to start launching everything. You are going to see here all the logs. Then now, in order to actually visualize the simulation, you have to click on the Gazebo icon. Okay, the Gazebo icon is this cube-like icon that we have here, also in the bottom bar. Then by clicking here, you are going to be able to visualize the Gazebo client, where you are going to see the simulation. Basically, it might take some seconds, even up to 1 minute or so to fully load everything. So here you can see that it's already being loaded, and there we go. Okay, so at the end you are going to have something like this, which is a GZ client window with an empty world, in this case an empty Gazebo world, and in the center, in the origin here, you can see the NanoSaur robot. Okay, the simulated version of the NanoSaur robot. You can zoom in to get closer to it, and here we have it. All right, so this should be what you have at the end after running this command here. Okay, so at this point we already have our Gazebo simulation started, launched here. Yeah, have you all been able to start this command? Do you have already the Gazebo simulation up and running? I got sick killed on client. Okay, up and running. Richard, can you try maybe to relaunch it? Everything should be okay. You might get some error messages here, as you can see, but don't worry about them. They are just Gazebo messages. So don't worry if you see these red error messages. Everything is going to be fine. Okay. Relaunching now. All right. Then yeah. Also, besides the Gazebo simulation, also, we have automatically launched an ROS2 application. I cannot see the robot model in ROS2, but this might come later. Okay, very well, Edgar, very well, yeah. So besides the Gazebo simulation, we have also started an ROS2. You have also started the ROS2 application, okay? Then in order to visualize the ROS2 window, as you can see, you have to click on this computer-like icon, which you have down here, which says it's for the graphical tools. Then by opening here, you are going to be able to see the ROS2 window. All right. Then by default, you are going to see here all the TFs with all the frames, etc. Then in order to be able to properly visualize the model of the robot, you just have to uncheck here robot model and check it again. Okay. then the visuals of the NanoSaur robot are going to appear, okay? This is an issue that exists in ROS2, so yeah, we have to do it like this. Good, okay, Edgar. And also you can see that we have automatically started here the camera, okay? So this is the camera of the NanoSaur robot. We are seeing here what the NanoSaur robot is, the data that the robot is getting from its camera, okay? So for instance, we can do a very quick test on this. In the Gazebo simulation, for instance, we can come here and let me get a little bit far away from it. And I'm going to spawn here something in front of the robot. So for instance, let me spawn here a sphere. Right here. I'm going to spawn it here. There we go, right in front of the robot. Here. There we go. And as you can see, the sphere automatically appears here in the camera. Yeah? We can even move a little bit this sphere around, and we should see how it is updated in ROS in the camera data. Okay, so let's move the sphere a little bit to one side, for instance. Let's move it here, and as you can see, it is updated also in the camera. Okay, it seems to be working now, says Richard. All right, great then. Okay, so yeah, basically we are done with the initial setup. We have started our Gazebo simulation here of the NanoSaur robot with an ROS2 visualization as well. And then at this point I'm going to stop and I'm going to comment a couple of things on the process we did in order to have this Gazebo simulation running. I'm not going to go over all the details, but at least I think that it is worth talking a little bit about the most important points, okay? So, first of all, probably the most important file here is the main.launch.py file, which is the one that we have executed here in order to start the Gazebo simulation, right? The first command that we have run here in order to start the Gazebo simulation, it's was this one. It was to basically start this main.launch.py file, okay? You can find the details of this file here in the notebook, but let's open it through the IDE so that we can have a better look at it. So in order to open the code editor, the IDE, it is this second icon here in the bottom bar, okay? It's code editor, as you can see. So if you click here, this is going to open the code editor, all right? Then here we can go to the ROS2 workspace, SRC, and then here inside the NanoSaur TC NanoSaur folders, you are going to find a new package here, a package which is named NanoSaur_Gazebo, okay? This is basically the main package that we created for Gazebo. And basically, it's very simple. So it only contains a world, an empty world in this case, which is the one that we are loading here, the empty world. We can already remove this, by the way. Let's move it aside. Otherwise, we cannot see the NanoSaur robot, which is the interesting part here. Okay, there we go. So, yeah, then this is one of the packages. Well, this is the main package that we created here for adapting the NanoSaur robot for the Gazebo simulation. Then here you have a worlds folder with an empty world in this case. We could load other worlds. In fact, for the next live class, we are going to be working on more interesting worlds than an empty world. And then we have here the launch folder with the main launch file. So let's have a quick look here at what's going on. So here we have a ROS2 based launch file, as you can see, since it is a Python script. Yeah, in ROS2, remember that launch files are Python scripts. Okay. Then basically we are here. We have the main generate launch description function, and we are defining initially here some files. like for instance the RV's configuration file that we are loading here, which we are defining the name here and storing all these file names in variables, so that we are going to use them later in the script, okay? Then the robot file that we are going to be using is this nanosaur.urdf.chakro. Okay, this is basically a URDF file that we adapted, let's say, from the original one. Okay, we did some modifications so that it can be loaded into Gazebo. So this file is located in the NanoSaur description package. Okay, and all this. So let me very quickly open here the original repo. Let me see. Where do I have the, okay. Yeah, so here you have the main repo, okay. So as you can see, this is the main repo, where you have branches in Foxy and Galactic. In this case, we are working in Galactic, okay. ROS2 Galactic. This is the version of we are working with. You can see here, which we are working on the ROS2 Galactic distribution. All right. Yeah, there Raffaello is sharing the main repo also. Then here you can see the original files. You have the NanoSaur description, NanoSaur control also for controlling the robot. And in the NanoSaur description package here, you can find the original URDF XML, okay? Then basically we based the URDF Chakro file on this one, of course, and we added some things to adapt it to Gazebo. So let's have a look here at the file. In our NanoSaur description package, inside the URDF folder, you are going to find this file, nanosaur.urdf.chakro. We can open it here, and then we are going to see the contents of it. Okay, I'm not going to go over all of it. It would be too much, and we don't have time for that. But yeah, basically, if you compare it with the original, you are going to see that it's quite similar. But we have added some extra things. Like for instance, we have added here a Gazebo file, which in this case you have it also here. It's in this case, this one what it's doing is to basically load the differential drive plugin in order to move the robot properly. Also, we are publishing some TFs required by Gazebo, TFs of the wheels, of the tracks, etc. We are also loading, for instance, if you come here at the bottom of the file, you are going to see that we are loading also the camera sensor. Okay, so we are loading here the camera sensor from another Chakro file, which in this case it's this one, sensors.chakro. Okay, but yeah, summarizing, so basically we have done some adaptations to the original URDF file, okay, in order to adapt it to Gazebo. All right, then yeah, let's keep going. So we are also defining here into a variable the NanoSaur Gazebo package, and finally the world file that we are using, which is this empty world.world. All right, then here we are generating some paths for the world file. As you can see, we are joining the file names with the packages, etc., so that we can get the full path to get to these files. Also for the URDF and RV's files, as you can see, we are generating the paths here with the OS path join function. Then next thing we do is to process the URDF file. So we are basically processing this URDF Chakro file that we have shown right now. We are processing it because we need to feed it to Gazebo. Okay, as you can see, for this we are using the Chakro process file function from the Chakro module, which we are importing up here. And we need to process this file because in order to load it into Gazebo, we need to have all this file in a string format. Yeah. So in order to be able to load this URDF data into Gazebo, we need to do it in a string format. Okay. So in order to be able to do this, we have to process it and we can do so with this process file function from the Chakro module. Okay? And then once we have processed the data, we convert it to XML, like this. Okay? All right, and then finally we are doing some replacements in order to prepare this for Gazebo. Okay, so in order for Gazebo to be able to read this data properly, double quotes, as you can see here in the comment, need to be with escape sequence. Yeah, escape sequence is this. So basically we are doing some replacements here to the contents of the file so that Gazebo doesn't complain when we try to load it. Okay? So as you can see, we have to prepare a little bit here the data. We have to prepare all this data so that we can then provide it to Gazebo, and then Gazebo is able to spawn the robot into the world. Okay? So here we are doing all the processment, etc., and preparing the data for Gazebo. And then here we are basically providing this data as arguments, which we are saving here in the spawn args. Yeah, so we are giving a name to the robot, and then here we are basically passing all the URDF data in XML format. All right? I know that this maybe might sound a little bit complicated, but well, I just want to talk a little bit about the process so that you get a better idea, and then later maybe you can investigate a little bit more by your own on all these files and what is going on behind. Is this only required in ROS2? Very good question, Edgar Carrasco. Yes, let's say that yes. In ROS2 there are some incompatibilities, and it's much harder to do all this process, let's say, in ROS2 than in ROS1. Okay, let's put it like this. Took a bit to get into the files with you, but I'm caught up now. Okay, great, Richard. Okay, so answering to Edgar's question, yeah, all these steps are required, especially in ROS2. In ROS1, all this process is much easier. Okay. Gabriela says that she has also caught up with us. Great, excellent. Okay, so yeah, as I was saying, basically what I want to do here is to point some things that we had to do in order to adapt all this URDF so that we could spawn it into a Gazebo simulation. Then, all right, so here we are running the robot state publisher, which purpose basically is to get the data from the URDF and publish all the TFs. Yeah, this is the main purpose of the robot state publisher. So all these TFs that you can see here, basically the robot state publisher is going to read the data from the URDF and is going to generate and publish all this TF data. So let's keep moving forward on the file. Okay, and then we finally create here the launch description object, where we are passing the robot state publisher node, as you can see, and then we are running some processes here using the execute process function. The first one is to launch Gazebo. So here we are basically starting Gazebo, and we are passing the world, okay? So we are basically starting this empty world. Okay, this empty world with the ground plane, etc., with nothing on it. So we first start Gazebo, and then we run, we call a service, a ROS2 service, which is this spawn entity. Yeah, as you can see, ROS2 service call spawn entity. So basically we are running this command, and we are passing the spawn args data. Yeah, this data that we have filled up here with the XML Gazebo information that we processed here. So basically we are passing all this information as to this spawn entity service, which purpose is to spawn the robot into the simulation. Okay, so it gets all the information from the URDF, process it, etc., and then it spawns the robot into the empty world. Yep, makes sense? And then finally, we are just starting ROS2. ROS2 with the configuration file. Okay, which starts by default this URDF screen that you can see here. Yeah? Makes sense, more or less? Did you get the general idea of what's going on here in this file? As I have said, you are going to have more time later to investigate more on all these, the different files, here, what's going on here, all the files that we are importing, the macros that we are creating down here, and so on, okay? So, yeah, so let's keep going once we have this. A final thing that I pointed here in the notebook is that this file, this URDF Chakra file that we created here for Gazebo, it's not compatible with ROS2, for instance. So we cannot directly load this URDF Chakra file into ROS. It's not going to work, okay? This is something that happens also only with ROS2. Yeah, this is an issue with ROS2, so ROS2 is still in development, and there are some things here and there that you are going to find, and you have to deal with them, which you are not going to find in ROS1, okay? But it's normal, it's still in development, and there are some things that are a little bit trickier to do than in ROS1. One of them is that these URDF Chakra files are not directly compatible with ROS2. You cannot load them directly, all right? Then in order to be able to load this file to ROS2 directly, what we had to do is to convert it first to URDF format, as you can see with this command, yeah? ROS2 run chakra, and then we can convert a chakra file into URDF format. All right? Then once it is in URDF format, we need to also modify the way in which we load the meshes. Okay? So by default, this command is going to put here in the file names the full path of these meshes, okay? So we need to update them so that they have this format. Package, and then we specify the package and the folder and file that we want to load. Okay, this is something that I just wanted to put here because it's something that might be a little bit tricky if you are new. So yeah, in case you are going to work with ROS2 and you are going to generate simulations and so on, this is something that can be useful for you. Playing around with it will definitely help. Exactly. So yeah, the purpose of these live classes basically is not to teach something very deeply because we don't have that much time, but it's to provide something to you, to all the attendants, is to provide you with a project which has everything ready and working, and then since you are going to get this copy in your workspace, you can open it whenever you want. So you can keep working when this live class finishes on this project. You can come back to it tomorrow or next week or next month, okay? So basically it's to present you with some information, with something useful that can work, and give you some points, and then later the idea is that you can keep working on them and investigating more on your own, okay? All right, so yeah, we can also have a quick look at the topics available on this Gazebo simulation with a ROS2 topic list command. So let's come here to the shell. I'm going to open here a new shell by clicking on the plus button here. And then here we can run a ROS2 topic list in order to have a look to all the topics, and we are going to get here a list with all of them. We have some topics which are related to ROS2, For instance, initial pose, goal to pose. We are going to see a joint states topic, a command belt topic, which you might already know that it's used in order to send velocity commands to a robot. We can find as well an ODOM topic, a TF topic, and the topics related to the camera, okay? From these topics is where we are getting the camera data, the one that we are visualizing here in RVs, for instance. Thomas saying, yeah, this is a great opportunity to learn without a real robot. Yet, exactly, yet. So we want to start working with a simulation and then move to the real robot because we believe that this is the best practice. Okay, we are not doing because we want to, but we strongly believe in the construct that the best practice when working with robotics, or usually the best practice, is to always try to develop a simulation of the robot you are going to be working with. Okay, this is going to allow you to do many tests, to create programs and test them without having to worry about the real robot, without having to worry about breaking something. So that's why we always like to start working with simulations, and then we try to recreate in the simulation the best or the most accurate, the better, the real environment, okay? And then this allows us to test many things, create programs, start playing with the robot without having to worry about and causing any kind of damage to the real one, okay? And then once we are comfortable with everything, then we can move to the real robot and start testing all the programs and everything that we have developed on the simulated environment. Then we move it to the real robot and we test it in the real robot. Yeah? Okay, so let's keep moving forward here. All right, so also keyboard celebration. Okay, so we have we can also run a teleobtuse keyboard node, which is it's very handy for controlling the robot in a very easy way. So we can, I'm going to directly copy this command here from the notebook and paste it here. ROS2 run teleobtuse keyboard, and then here at the end we are doing a remapping from command bell, which is the default topic, to NanoSaur command bell, which is the command bell topic of our simulation, as you can see here, right? Then if we run this command, we are going to start a ROS2 node, which is going to allow us to control the robot, to move the robot, using the keys in our keyboard, in a very easy and intuitive way, okay? As you can see here, you have also an image here, an illustration of how you can control the robot with the keys. So basically with the I key, you are going to move it forward. With the J, you are going to turn left, turn right. With the K, you are going to stop the robot, etc. Okay? Then this allows us to be able to control the robot using the keyboard. Okay? I'm going to do it very quickly now here to test it. So for instance, now, as you can see, I am moving it forward. I can turn to the left. Okay? I can turn to the right, etc., etc. Okay? Yeah, you can test it also there, launching this program and playing a little bit with the robot, moving it around. Okay? And we are going to stop it here also with the K key. Okay? Then once we are done playing, we can stop it. Okay? All right, so let's keep moving forward and let's get to the final part of this class, which is to create a basic ROS2 program to interact with the simulated robot. Yeah, so have you been able to test the teleop keyboard node? Have you been able to move a little bit the robot? Yeah? All right, so let's then create a basic ROS2 program, okay? Very, very basic. So we are going to create a package, which we are going to name NanoSaur Tools. Okay, and then in this package is where we are going to be placing all the different programs, etc., that we create for the NanoSaur. So let's come here to the NanoSaur folder. First of all, let me make this a little bit bigger. There we go. And then we are going to run the command down here in order to create the package, okay? This is going to create a new package, a new ROS2 package, as you can see, with the ROS2 package create command, a Python package, which is going to be named NanoSaur tools, and then we are just providing some dependencies for this package. Then we are going to be able also to access this package directly here from the code editor. Yeah, we are going to find it here, and at this point it's empty. It just has some files and folders that are created by default. So the first thing we are going to do, as you can see here in the notebook instructions, is to create this move.py script, okay? We are going to create this Python script here inside the NanoSaur tools folder. Yeah, we have the first NanoSaur tools folder, which is the package folder, and then inside we have another one, which has the same name. So we are going to create our Python script in this second one. This second NanoSaur tools folder is the one that contains the init.py, okay? So here we are going to create a new file, move.py. There we go. Okay, and then inside this file, which is empty at this point, as you can see, we are going to copy the contents here of the notebook. Yeah, here in the notebook you are going to find the contents of this Python script. So we are going to select all this code, copy it, and paste it directly here. All right. So let's have a super quick look here at the script. It's super basic. So basically, it's just a ROS2 node where we are creating a publisher for the command belt topic, and we are creating a subscriber for the ODOM topic. All right. And then we are going to be reading the odometry data and storing the data of the position in the x-axis of the robot. We are going to be storing this data in this pose_x variable, okay? Then in our move function, we are going to basically create a very simple logic here, which says that if the position x value is lower than 3, then I'm going to move the robot forward. Then else, so if the position in the x-axis of the robot is higher than 3, then I'm going to stop the robot. Okay, so I'm going to only allow to move the robot until it reaches the position x value of 3. All right? So basically, once we launch this program, what should happen is that the robot in the simulation is going to start moving forward, okay? It's going to start moving in this direction until it reaches a position in the x-axis of 3. When it reaches this position value, then it's going to stop, okay? So basically, this is what should happen. So let's keep going. And then we are going to create also a very simple launch file for this, for starting this program. So let's come back to our code editor. And inside the NanoSaur tools package, in this case, we are going to create a new folder named launch. Okay? And inside this folder, we are going to create a new file named move.launch.py. All right? And then here we are just going to copy and paste the contents also that you can find in the notebook. Yeah, super simple as well. We are creating here a launch file. We are going to basically launch the move node executable from the NanoSaur tools package. So what's the last thing that we need to do? Well, we need to actually generate this executable. Then for this, we just need to update the setup.py, okay? I have also put directly here the contents of this file, so you can basically copy it directly also from the notebook and paste it here, okay? And again, super simple. Here, as you can see, we are generating this move node executable from our move script. Yeah, so we generate this move node executable here, the one that we are launching in our launch file, and then also you can see in this line here, that what we are doing is to install in the system all the launch files that we have in our launch folder, which in our case is only this one, the move.launch.py. So we are installing this launch file in the system. All right? Okay, so now, yeah, nothing else to do. Now we are ready to compile. So let's come here to the ROS2 workspace and compile with the colcom build command. Okay, we are going to compile our package, NanoSaur tools, and once it finishes compiling, we are going to source, and now we are ready to run our command. So ROS2 launch NanoSaur tools and move.launch.py, right? I am auto-completing everything to make sure that everything is working. And then I can run the program and I should see my robot start moving forward. I'm going to get also data on the position X value. It's 2.7, 2.9, and as soon as it reaches the value 3, as you can see, the robot, it stops. All right? Okay, so yeah, basically we are done. So let me try to summarize a little bit what we have done for today's live class. So at least the most important things that you need to get in mind. So let me summarize very quickly. Remember that this live class, okay, is a part of a series of live classes which we are going to be doing with the NanoSaur robot. Okay, this super nice green robot that you have here, which is based on the NVIDIA Jetson by NVIDIA, and which has been created by Raffaello Bonghi, a friend of us, which is also here in the chat, in case you want to say thank you to him. Okay, so we are going to be doing 4 live classes during this month of November. Then the first one, which is today's live class, of course, we have been working with the Gazebo simulation, okay? So we created a Gazebo simulation of this robot, and we have been testing a little bit this simulation, doing some tests with it, launching it, checking which topics it is providing, and we have created a very simple ROS2 program to interact with this robot in the Gazebo simulation, okay? So we have the basics prepared, and from this point we are going to be building up. Then in next Tuesday, next live class, November the 9th, we are going to be going a step further, and we are going to develop more complex ROS2 programs to work with the NanoSaur robot, based on AI in this case, okay, which is going to be super interesting. So you better not lose the next live class. You cannot miss it. Then in the next live class, we are going to actually build the real robot. Okay, so we are going to build here live in the live class. We are going to prepare some special cameras here so that we can build all together the robot. Then for this, in case you want to build the robot together with us, which would be super cool, then you can find here all the materials you need to get. Here you have the main materials, the materials for the expansion board, which we are going to have to mount previously to this live class. You are going to find all the data here, don't worry. And also you are going to need to print some parts of the robot, okay, to 3D print some parts of the robot. All right, you are going to find all the information here in the notebook, and also Raffaello has said that he's going to be around in the Discord page, so in case you want to join their Discord, he's going to be around there helping you, and probably you're going to find other users, other people who is working with the NanoSaur robot, which also are going to be able to help you, okay? Yeah, so once we build our real robot, then in the final live class, what we are going to do is to connect here from a ROS like this one. We are going to connect to the real robot, and we are going to control the real robot. Okay, and we are going to show you how to do it and how you can do that also from your places, from your computers, how you can connect very easily to the real robot. All right. So yeah, that's all for today. Thank you very much for being here. I can see here. Let me check the last messages. Richard said, not caught up with you, but this has been very informative and understandable. Thank you. Okay, Richard, don't worry. You can have a review at the notebook now at your own pace. These live classes, we have a limited time, so sometimes they are kind of fast. But yeah, don't worry. You can review also the video once we upload it to YouTube, so you can review the video and pause it, etc. Joel is saying, could you please show the commands to compile and run? They are not in the notebook. Okay, sorry, I missed that maybe. Okay, Joel, so to compile the commands, the command is colcon build. Okay? Colcon build. Let me paste it here in the chat. And to run it, the command is like this, okay? Let me also paste it here in the chat. Okay, so also let me remind you, I have added here at the end, so in case you are not familiar with this colcon build command, ROS2 launch, these are basic ROS2 commands, which in case you want to learn more or you need to learn more about ROS2, we have a super nice course in our academy. You can find the link here. If you click on the image, this is going to take you to our course based on ROS2, okay? ROS2 basics in 5 days, based in Python. You have also the version in C++, but basically this course is going to teach you all the basics that you need to know about ROS2. Like, for instance, this, how to compile, how to launch programs, etc. Let me see. Are these all in Python? Do we work with CPP version also? I don't think so, Ash2. So for these live classes, we are going to be working in Python. In Python, which is more simpler, and it's going to be easier to deal with in these short live class sessions. So yeah, we are going to be working in Python. I realize that's not what you meant, I think. Okay, yeah, I think that I already answered. Joel also Raffaello, thank you for this cool lesson. Thank you for your words, Raffaello. Thanks to you for building this super amazing robot. So, okay, Thomas is leaving. May I add change to the directory ROS2 workspace to compile? Okay. Yeah, you can modify anything if you want, Edgar, in this project. You can change things. So now you have a copy of this project. This copy is yours, so you can do whatever you want here. You can create your own programs, etc., etc. It's your own project. So yeah, let's leave it here. Thank you very much for being attending to this live class. Thank you also for being active in the chat. it's very nice for me to have this interaction in the chat. So thank you very much for that. And yeah, I hope that all of you get the pieces for the robot, and let's build this NanoSaur robot together during this month. Okay, so yeah, thank you very much to all of you. I'm going to leave it here. So I will see you next Tuesday with the next live class on ROS2 Artificial Intelligence with the NanoSaur robot. And until then, take care and keep pushing your ROS learning. Bye bye.